Hey guys, good morning, good afternoon, good evening. I'm not sure what time you're watching this. First of all, thank you so much for clicking play. Secondly, all the best for those who are working very hard for their PSP. This time, what we are going to cover? We are going to cover on checking whether it's differentiable or not using first principle. Without further delay, let us on the count. 1, 2, 3, let's go! Right, hi everyone. So differentiability, right? What does that mean? We want to go and see from our graph what it actually means. So as you can see here, okay, if you have a corner, say at point A, this guy is not differentiable, meaning to say, if you go and check the differentiability at A, it's not differentiable. If you got a jump like this, it is not differentiable at A. Thirdly, if you got a gradient which is parallel to the y-axis, it is not differentiable. Okay, so this is just a picturization of what differentiability means. All right, okay. So basically, okay, what does this mean in terms of calculation? Say for example, right, I give you fx equal to x squared. Of course, now if I ask you to differentiate, you would give me 2x. And if I go and ask you for f prime of 3, it's just like place of x has been replaced by 3 and you're going to give me 6. So now if I ask you, is it differentiable at x equal to 3? Of course you can say yes, because you can give me a value. In other words, we can say f prime of 3 exists because there is a value. So just now the first slide, what you saw was, okay, I saw a picturization of what differentiability means. Now, to get an idea what does differentiability means is, if say it is differentiable at 3, I can just say I have a value. This is just a rough idea what differentiability means. So basically in this chapter, what we are going to do is, we're going to use the first principle to check the differentiability at point x equal to a. So how on earth are we going to do that? We're going to do that using this formula. So meaning to say, if we were to check the differentiability at x equal to a, what are we supposed to do is, we are supposed to go and see, is this guy exists? Okay, is this guy exists? In order for this guy to exist, this limit should exist. And in order for this limit to exist, we must go and find first the limit from the right and the limit from the left. Why? Because by now, since we have covered chapter 8, you should know existence of limit is limit from the right and limit from the left. They should be the same. If they are same, then the limit exists. Right, so let us go and see a simple function that you already have a clue, that you already have drawn since your chapter 5. Okay, so you know very well how does this graph look like. Yes, it's a modulus function with a V shape. Okay, with the V shape. Okay, trying to show my this thing. Okay, so V shape, you know, it has got a sharp bend at 1. Okay, so if you know how to draw this graph, of course by now you should know how to draw this graph. If you don't know, then you are at serious risk. Please go and see how to actually draw the modulus function. So I want to check its differentiability at x equal to 1. So how do we do this? Since we are using the first principle, I need to write down the formulae. Okay, so let us go and see the formulae. So this is the formulae that I'm talking about. You want to check differentiability, this is the formulae that you need to write down. So since I am checking the differentiability at x equal to 1, that would be the value of a all being replaced by 1. Okay, so I'm going to go and replace a with 1. Why? Because I'm interested at this particular point. So now if they ask, is it differentiable at x equal to a, it simply means, does this guy exist? The next question is, the existence of this guy depend on the existence of this guy. So existence of limit. So as we discussed just now, existence of limit simply means does the limit from the right and the limit from the left, are they the same? So we need to go and analyze that. So in order to analyze that, what we need to do is, first of all, we need to go and define this function. Okay, so let us go and do that. We know very well modulus of x is x when x is greater than or equal to 0, and negative x when x is less than 0. This is modulus of x definition. So I want to go and work out the definition for modulus of x minus 1. So that would be, if you can see here, right, the place of x has been replaced by x minus 1. So what I'm going to do, I'm going to go and replace each and one of these with x minus 1. You can see here, I already do that. These guys, I just copy only. I just copy. All right. Hope you're clear up until there. Need to sort out this guy because this is interval. So I bring this guy over this side and this guy over to this side. So as you can see here, okay, this is the definition for modulus of x minus 1. I would suggest to you, strongly recommend to you to do your derivation, okay, for the modulus function using this so that you can minimize your careless mistake. So now what I need to do is I need to go and evaluate the limit, okay, from the left and from the right. Let us do that. Okay, so I want to go and evaluate limit x approaching 1 from the right for this. So what I need to be careful is I need to select the function correctly. So as you know, x approaching 1 from the right, x approaching 1 from the right. So I know if from the right, the values in comparison to 1 is definitely going to be more than 1. So the place of fx, I'm going to go and replace with x minus 1. Why? Because x is bigger than 1 since I'm approaching from the right. And then I need to evaluate f of 1 using the function that I travel. Please take note, this is the one student always make careless mistake. You need to evaluate f1 based on what you're traveling on. So x approaching 1 from the right, we are traveling on this, so you need to sub f1 into this function. So we will get this. Okay, this one f1, evaluate, put 1, 0, get that. I can see that at the top I got x minus 1, I got x minus 1, that's going to cancel. So when you give me limit of 1, it is just going to be 1. Limit of a constant is a constant. Okay, hope you are clear up until there. Since we are done with the right, I need to go and evaluate limit x approaching 1 from the left. Okay, so similarly, we know that as I approach 1 from the left, the values in comparison to 1 is going to be less than 1. Okay, it's going to be less than 1. So I'm going to go and apply this function. I'm going to go and apply this function. Okay, so f of 1 now you evaluate using the function that you're traveling on, which is this guy. Okay, so as we put 1 again, you would get the same value, which is 0. So I just have negative x minus 1 over x minus 1. You will simplify. Limit of negative 1, limit of a constant is just constant. So I just get it. So you can see here, limit x approaching 1 from the right, you get 1. Limit x approaching 1 from the left, you get negative 1. So what does that tell us? Now we can go and analyze this guy. Okay, because just now I want to go and find, is it differentiable at 1? Meaning to say, does this guy exist? That would mean, does this guy exist? In order to check existence of this guy, we go and evaluate from the right and from the left. Since I know limit from the right and limit from the left is not the same, it is safe to conclude this guy do not exist. Because this guy do not exist, that's going to affect this guy. This guy doesn't exist as well. And we can safely conclude it is not differentiable at 1. So let us sum it up. So limit doesn't exist. This guy doesn't exist. Conclusion, fx is not differentiable at 1. It is very important for you to wrap it up like this. Write your working like this so the examiner is very clear of your intention. And going back to the brief idea that I gave using the diagram, this is how your modulus function looks like. As you can see at 1, there is a sharp bend. So because there's a sharp bend, okay, there's a sharp bend, it is not differentiable at this 1. And normally they will try to relate with continuity. So as you can see here, although it is not differentiable by one, it is continuous. Okay, tiada jam mah, memang dia. Okay, so hope this example does make sense to you. I'll put in some questions for you to try from the past year. So hope you try that and you make sure you nail this, okay, finding whether it's differentiable or not using first principle. All right, people. Ciao. See you in the next videos. Yes, we are not far away. Keep working. Much love. Bye bye.